Today we're going to start with section 4.1, exponential functions, graphs of exponential functions, and compound interest. So, section 4.1. Exponential functions. So the first thing we have to do is decide what an exponential function is. So an exponential function with base A is defined for all real numbers x by the following: f of x equals a to the x, where a is greater than 0, which means that it's positive, and a cannot equal 1. So basically, what are we seeing here? We're seeing a is the base and x is the exponent. So we're seeing that in an exponential function, the independent variable is in the exponent. So the variable, the unknown, the input, is in the exponent. That's why we call it an exponential function. So now let's ask a question. Okay, is this an exponential function? True or false? Exponential function or not an exponential function? It's got an exponent. So what did we say had to be true for it to be an exponential function? The variable, the x, has to be where? In the exponent. So does this one have the variable in the exponent? Now we know by looking at this that it's not an exponential function because we've already talked about this kind of a function. This graphs a what? Graphs a parabola. And we said that this was a what kind of function with has a squared term? A quadratic. So this is quadratic, whereas this is exponential. So you have to remind yourself the variable has to be where? In the exponent. Okay, we're going to look at another example. F of x equals 2 to the x. Exponential function or quadratic function? It's got a 2 and it's got an x. So now where is the x? The x is in the exponent. So this is an exponential function. So the emphasis is to pay attention to where the variable is. So we're going to look at a couple other ones. We've got f of x equals 3 to the x, exponential function because x is in the exponent. Now, what did we say the name of the 3 was? The 3 is the a. The a is the what? The base. So this is going to have 3 as our base. And this one, if I had g of x equals 10 to the x, this would be still an exponential function with base what? Base 10. So the a is the base. So now we're going to look at evaluating an exponential function. So I'm going to evaluate. And I'm going to start with the function f of x equals 3 to the x. So if I want to find f of 4, this is 3 to the 4 because this input is 4. We're inputting it into the variable. So 3 to the 4th we know is going to be 3 times 3 times 3 times 3, which comes out to be 81. Okay, grab your calculators. So the next thing you're going to look at is, what if I have f of pi? Pi is a number like 4 is a number. So what do? We plug it in again to the x and get 3 to the pi. So we're going to find approximately on our calculators. Let's go 2 decimal places. So if I plug in 3 to the pi into my calculator, I'm going to get 31.54. So you get the idea? Give everybody a chance to catch up to that point first. The next thing we're going to look at is graph. So we're going to graph f of x equals 3 to the x by plotting points. Now I know you can do it on your calculator, but we're going to figure out how to do it on plotting points. So we're going to have an XY chart. And we're going to be graphing. F of x is the same thing as y, so we're going to be graphing y equals 3 to the x. So again, what is our input? Is our input the x or our input the y? So our input is the x. So we're going to start plugging in numbers for x. So we're going to plug in -2, -1, 0, 1, and 2. So I get 3 to the -2. Now, we've talked about exponents before, so a negative exponent is the same thing as saying the reciprocal of, so that means moving this 3 squared to the denominator, so I get 1 over 3 squared. If it's negative in the top, it's going to be positive in the bottom, so a +2, so this would be 1/9. The next one we're going to do is 3 to the -1. Same idea, this negative sign is reciprocal of, so I get 1 over 3 to the first, or 1/3. The next one I have 3 to the 0, we're still plugging into x. So 0 power, we know that anything to the 0 power is what? 1, good. So now we've got 3 to the 1 and 3 to the 2, and those are obviously, we know, 3 and 9. So my ordered pairs, -2, 1/9, -1, 1/3, 0, 1, 1, 3, 2, 9. So we're going to plug those into our picture. So we have 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to go to 10. And then we're going to go 1, 2, 1, 2. So here's my origin, this is my x-axis, and this is my y-axis. So I'm plugging in -2, 1/9. So -2, 1/9 is just barely off the line. -1, 1/3 is a third of the way up. 0, 1, 1, 3, and 2, 9. So now we do dot to dot. And so we get y equals 3 to the x, or f of x equals 3 to the x. Now, one of the things we want to look at here is, can I go into the negatives down here? Can I go below the x-axis, or can I even go on the x-axis? Is there anything that I can plug in that's going to make y to be 0? Because when I plugged in 0, I got a 1. So there's nothing. So what does that make this horizontal x-axis be? Well, we know that that's going to be our asymptote. It's never going to pass across there, because a is a positive number. We said a was positive, right? Now, the other one we're going to graph on this same graph is we're going to graph g of x equals 1/3 of x, 1/3 to the x. So we're going to make our chart again, x and y. So we've got, to figure out which thing we're plugging in. Again, we're plugging in for the x, right? So we get -2, -1, 0, 1, and 2. So when I plug in -2 this time, I get 1/3 to the -2. Now again, we said the negative was reciprocal, right? So if I reciprocate this, I get 3/1 to the +2, which means 3 squared is 9. So now I do the -1 the same way, 1/3 to the -1. So this is going to give me 3. 1/3 to the 0, anything to the 0 power is 1. Next one, I put in a 1, so 1/3 to the first power is just going to be 1/3. And 1/3 to the second power is going to be 1/9. So what's going to happen to our graph when I switch that and make it be 1/3 instead of 3? So let's plot our points. -2 now is going to go up to 9 on this side. Whoops, 9 would be here. And the next one, what are we going to do? Then we have -1, 3, 0, 1, 1, 1/3, and 2, 1/9. Now this time I'm going to dot it in just so we can see the difference of which one we're talking about. It doesn't mean that it's an asymptote. So this side over here is going to be our g of x equals 1/3 of x. Now, when we look at graphing, we're going to make some comparisons, okay? The graph, as we look at this one, here we got 1/3 of x, and this one is x to the first 3x. So we have y equals 3 to the x, and then this one is y equals 1/3 to the x. Now, what did we say we could rewrite this as again? If this was a +1 in the bottom, we can flip to the top and be y equals 3 to the -x, right? So what did we learn before when we did transformations? So if I look at transformations, what did we learn? If the negative was on the inside, then it reflected where? Across the y-axis. So you can see how this reflects across the y-axis. So this one right here and this one right here are related to each other in that way. Transformations from this one to this one reflects it across the y-axis. Now, the other thing I want to look at is how do we tell whether it's going to start from the left-hand side here or whether it's going to start from the right-hand side. So is it going to go high to low or low to high? So we're going to look at that. So we have graphs of exponential functions. So we're starting out f of x equals a to the x, where a is positive and a cannot be 1. So we're going to look and see what some of the conditions are. So if a is greater than 1, still a positive number, greater than 0 is still positive. So the graph, if a is greater than 1, the graph is going to start low and go high. So it's going to start low and go high like that. So how do we have an example of that? Well, a is my 3, so 3 to the x, 3 is greater than 1, right? Okay, the other one we're going to do is if a is between 0 and 1. So a is between 0 and 1. So that would be an example of the 1/3 then, right? 1/3 to the x. So what did we see that happening? 1/3 of the x started high and then went low. So if we have some numbers that are between 0 and 1, then we know it's going to start high and go low. Does So that gives us some things to think about when we're looking at the graphs. If it's greater than 1, start low and go high. If it's between 0 and 1, then it's going to go high to low. Now, again, what did we talk about? This horizontal line here, the x-axis, is going to be our horizontal asymptote. So this is our horizontal asymptote. Okay, give everybody a chance to catch up to that point. Okay, let's look at some other transformations. If I start with y equals 2 to the x. Now we can graph that one just as we graphed the other one. So we know this graph is going to look something like what? Going up here like this. So we've got 1, 2, 1, 2. So if I put in -2, this is going to be up here. -1 would be 1/2. 0 would be 1. Put in a 1 would be 2. Put in a 2 would be 4. 1, 2, 3, 4. Okay, so we're just plotting the points as if we put in the -2, -1, 0, 1, and 2. So how is this being our parent function going to change, or how is it going to transform into something like this? G of x equals 1 plus 2 to the x. What is the graph going to do when we do 1 plus 2 to the x? You're still going to start with this 2 to the x graph, but then the plus 1 does what? Causes everything to do what? Move up 1. Now, it not only moves all the dots up 1, but it also moves our asymptote up 1. So when I say this plus 1, this moves up 1, and all the graphs move up 1. So this would be the 1/4, this would be the 1/2, this would be the 1, this one's going to go up 1, and this one's going to go up 1. So our graph looks something like that. So everything moved up 1. So the bottom one is our y equals 2 to the x, and this one up here is going to be our 1 plus 2 to the x graph. Now, using those ideas, the same kind of thing, we'd do another transformation. What happens if I have h of x equaling -2 to the x? Now, that last one we looked at, when we had this one with the 3, the negative was inside the function. So when it was inside the function, we said that it reflected across the y-axis. So now this one has the negative on the outside. So if our original graph looks something like this, how's that going to affect it? Well, we know that that's going to reflect it across the x-axis. So we know our new graph is going to look something like this. So this one would be my y equals 2 to the x, and this one is going to be my -2 to the x, because all these are going to reflect across. So you get the idea? Okay, what is one that looks like this going to do? Let's call it k of x, 2 to the x minus 1. Now this one's inside the function, because we talked about outside the function moves it up and down, inside the function moves it left and right, the opposite of what you would expect, right? So you would expect -1 would take it to the left, but it really goes to the right. So this is going to go to the right 1. Everything's going to move to the right 1. Excuse me. So we start with our original graph. This one would move to the right, this one would move to the right, this one move to the right, and all of them would move to the right 1. So your transformations are the same kind of things that you've been used to before. inside the function, outside the function, reflect across the x-axis, reflect across the y-axis. So you got all those different transformations. Okay, we said another thing that we were going to talk about was compound interest. So does everybody have the transformations before I move the page? So we're going to talk about compound interest. Now, if you have a savings account at the bank, then you get interest on your account. Interest is the amount of money they give you for using your money. So in this case right here, we're going to talk about calculated in number of times per year. So we're going to talk about that in a second, but let me write the formula down first. A parentheses T equals P1 plus R over N to the NT. So what is my input in this problem? My input is the T, right? This is saying the amount after a certain amount of time T. It does not mean multiply by T. It means the amount of money after time T. So this would be function notation. Now, a lot of times we just leave the T off, but for right now, for the formula, this is the way it looks. So in this formula, the P is going to be the principal. Now, the principal is the amount of money you're putting into the account. So principal is the amount of money you're putting into the account. The R is going to be the rate, and it's going to be the percent per year. The next one is the N. The N is the number of times that they give you interest in your account. So number of times it's compounded per year. So number of times the interest, or let's say the account, is compounded per year. And then T is going to be the number of years. Now, when we talk about N as the number of times the account is compounded per year, we have to understand what kind of words we're using. So N can be one of the following. Annually, so that would mean N was one time per year. Semi-annually, okay, that's going to be N is 2 times per year. Okay, now this one should be pretty obviously. Quarterly, how many quarters are in a dollar? Quarterly is going to be N equals 4 times a year. Monthly, how many months do we have in a year? We have 12 months, so N is going to be 12. We have weekly, so N is going to be 52 weeks in a year. And then the last one we have daily. So N is going to be 365. Oops, 65. So give everybody a chance to catch up to that point. Okay, so we're going to look at an example. So the example is going to say $1,000 is invested at a rate of 12% per year. What would be in the account after 3 years, compounded monthly? So we go back up to the top to our original formula. We're going to rewrite it without the a of t. We're just going to write a equals p 1 plus r over n to the nt. Again, we know that this is a exponential function because the t is our unknown and it's in the exponent. So our p is our principal, the amount of money we're putting into the account. So we have a equals 1,000, 1 plus. Now r is our 12%, but we can't put percent into the equation, so we're going to have to change it to decimal. So percent per 100 means we divide by 100, so it moves the decimal 2 places to the left, and we get 0.12. So 2 places to the left. So you're going to get 0.12. N is the number of times monthly, so monthly, 12 months in a year, so I get n equals 12. So that goes in for n. And so I have 12 for the n again, and then 3 is the number of years, so I have 3. Now, you know what 3 times 12 is in your head, so that you can just put that into your calculator as a 36. But we want to, if we want to put this into the calculator, I encourage you to put it in where we put parentheses around that. So I'm going to say a equals 1,000, 1 plus, and then I'm going to say parentheses 0.12 divide 12, parentheses, parentheses. So you have to have 2 parentheses at the end. This one makes this one be the parentheses. And then this one ends this parentheses, and this one ends that parentheses. And then we could just say 36 up here. Now, if these numbers are really odd numbers, then we can't do it in our head, then we put parentheses around it to make sure you know that that's the whole exponent. So when I put this into my calculator, I'm going to use the caret top to make the exponent, and I'm going to come out with a is approximately, since it's money, we're going to go to the nearest penny. So we get $1,430.77. So we start out with 1,000, and 3 years later, then we have $1,430.77. And so that would be compound interest. Okay, we're going to try another one. Give her a chance to catch up to that point first. Okay, we're going to try another one. This one says that you have $500 invested. And it's invested at an interest rate of 3.75% per year, compounded quarterly. Find the value after 2 years. So we plug it into our formula. A equals P 1 plus R over N to the NT. So we have A equals, our P this time is our 500. 1 plus R, so now we have 3.75%. Again, to get rid of the percent sign, we have to move it 2 places to the left. So that goes away, and I get 0.0375. So that's going to go in for R. But we're going to go ahead and put that parentheses around it. 0.0375 over N, but N is quarterly. Quarterly means N is 4 times, right? So we're going to put in a 4 in that parentheses and in that parentheses. And I'm going to get N, which is 4, times T, which says is 2 years. So when I put this in my calculator, I would put this in as an 8. So give everybody a chance to plug it in their calculator and see what they get. So rounding it to the nearest penny, you should get $538.75. Okay, now, so far everything that they've given us the equation first. and then we have to go to the graph. Well, now they're saying I'm going to give you the graph and I want you to tell me what the equation is. So we're going to find the exponential function that goes with the graph. So find the exponential function that goes with the graph. So they're going to give us something that looks like this, exponential function, and they're going to tell us that this point right here is -1/1/5. So we know that it's an exponential function, so it's going to be f of x equals a to the x, or y equals a to the x. So our job is to find the a and the x and the y that make this into a exponential function like that graph. So my -1/1/5 is an ordered pair, x comma y, right? So we take x and y and we plug them into the x and y. So y is 1/5, x is -1. So this is either you can bring this to the top or you can bring this to the bottom. It doesn't matter which way. So if I say 1/5 equals, to make this positive, I'd move it to the denominator. So 1 over a to the first. So 1 over 5, 1 over a, that tells me that a equals 5. So now I take the 5 and I plug it in for a. And that's where my function is. F of x equals 5 to the x. Okay, let's try another one. So this time they're going to give us starting high and going low. And this point up here is going to be -3, 8. Now, what does that tell you? Something about if we know that this one went up high and we came out with 5x, this one's going to start high and go low, so we're going to come out with what? A number between 0 and 1, right? So again, we're starting out y equals a to the x. So I've got -3, 8, which is my x comma y. So I'm going to plug in 8 for y. And I'm plugging in -3 for x. So when we do this one, we're going to take and rewrite it. So I get 8 equals 1 over a to the third. So I can put this in over 1, and I can cross product, because I have a proportion, two fractions equal to each other. So this is going to give me 8a to the third equals 1. But I'm still solving for a, right? So I'm trying to get rid of that 8. So I'm going to divide by 8 on both sides. So the 8's cancel out, and I get a to the third equals 1/8. But I'm still trying to find a, not a to the third. So I'm going to take the cube root on both sides. And that tells me a is 1/2, because I know 2 times 2 times 2 is 8. So to get my final answer on this one would be f of x equals 1/2 to the x. So it came out like we anticipated, that this one was going to be greater than 1 and this one was going to be between 0 and 1. So that takes us through section 4.1.